Alrighty, we're looking at adding fractions today. A few examples. We're going to start with like fractions with the same denominator. So if we're looking at tenths and tenths here, we can represent these pieces like this. And you'll see that if we kind of add up everything we've got, if we put it all in here, we're going to have a total of 1, 2, 3 tenths from the fraction on the left, another tenth from the fraction on the right. Our total is going to be equal to 4 tenths of this whole we've drawn here. So all we do to add these fractions is we just add the tops and the bottoms stay the same. Let's make a note of that. Add tops, the numerators if you will, bottoms stay the same. With unlike fractions, the unlike denominators, our half would look like this. There's our 1/2. Our 3 tenths would look like this. So we can't just combine those pieces because they're different shapes. We wouldn't be able to figure out how much we've got. But what we can do is break this up. So now we can redefine this as 5 tenths. We've still got 3 tenths. Now if we put our pieces together, we've got 1, 2, 3, 4, 5 tenths from the fraction on the left, which was a half, still is a half. 3 tenths from the fraction on the right, so we've got a total of 8 tenths. And you'll see what we did is we added in kind of a first step. We made denominators the same, and we're using the least common multiple. And then we do our second step, which was we add the tops, and the bottoms stay the same. So here's kind of the math version, right? We took this guy, we multiplied it by 5/5, so that gave us our 5 tenths, and then we added our 3 tenths. So what ends up happening when we put the pieces together in here is we add up the tops, 8 tenths in total. And now a better way to write this is actually to reduce it. Looking for that greatest common factor, reduces down to 4/5. You know what? I should have done that up here too. This guy can be reduced. You can divide that guy by 2 top and bottom, and that guy reduces to 2/5. So if we're thinking in steps, let's put in a step 3 is reduce. Or you could say write your answer in lowest terms, but either way, that's what's going on. Make the denominators the same, add the tops, the bottoms stay the same. Then we reduce. Now when we get to mixed numbers, it's a little different here. We've got 6 3/4 and we're adding 2 1/2. So what I would suggest you do, there's 2 ways to do this. We'll do it both ways. I think first it's easiest to make this guy into quarters because we know that's our step 1. So now I've got 6 3/4 plus 2 and 2/4. We could just kind of line it up like this: 6 3/4, 2 and 2/4, and we could just add old school. We get 8 on the left. Here we've got 3/4 and 2/4, so we've actually got 5 quarters all together that we're adding up. But now we've got to take this 5 quarters and look at that perhaps like this. It's actually 4 quarters and a whole, right? And 1 quarter. 4 quarters being a whole plus 1 extra quarter. So all together, this is actually 9 1/4. So we had 8 here, 6 and 2 made 8, and then we pulled away 4 quarters to make 9 quarters, 9 wholes, and then our 5 gave us 1 quarter left over. So there's our 1 quarter. That's one way to do it. You can see it gets a little weird. There's some strange things happening here. Perhaps an easier way to do it is to start with that 6 3/4. Let's say we've already converted. We've got 6 3/4, and we had our 2 2/4 because we knew those quarters are a good idea. Now we can do our multiplication and addition step. We can make our mixed number into an improper fraction. So we had 24 plus 3/4 here, plus we're going to multiply the bottoms. 2 times 4 is 8, plus the 2 on the top, quarters. So we've got 27 quarters plus 10 quarters equals 37 quarters. Which is actually the same as 9 1/4. If we check here, 4 times 9 is 36, plus 1 is 37 over 4, and our answers work. Alright, so two ways to do that mixed number question. You can kind of line it up, straight up and down, or you can make them into improper. Oh, improper fractions, and then use those. Alright? Jumped ahead here, but we're looking at next a mini bike question. Example 4, we're repairing a mini bike. It says it took 1.5 hours to repair the chain assembly, 1 3/4 hours for an engine tune-up. And it says if labor costs $25.50 an hour, what is the total cost? So I'm going to write down my information. I have 1.5 hours for chain repair. I have 1 3/4 hours for the tune-up, and then I have $25.50 per hour. I'm looking for the total. So now, hopefully we can see here what we need to do is put together all of this. We have 1 1/2 plus 1 3/4. I'm going to add it up top to bottom here. We'll go up. We'll do our step 1. Make the denominators the same. So we times 2 top and bottom here. We've got 1 2/4 plus 1 3/4 now. We get back into that weird situation. We've got 2 5/4. So we're going to break this 5/4 up, which means we actually have 3 wholes and 1/4 left over. Alright, if you want to do it the other way, go ahead and try it and see what you get. You'll you make that 1 2/4 plus 1 3/4, so you make this into 4 plus 2, 6/4, plus 4 plus 3, 7/4. You'll have 13/4, 3 1/4 left over. So either of these is a good answer. And now we're still looking for our cost. We haven't got to our cost yet, right? And next time, this is the time to go back and read that question and ask yourself, did I find the answer? So now we're going to do 13 over 4 times 25.50. And to find our total cost. 13 over 4 is going to be equal to 3.25. 13 divided by 4. Divided by 4 equals 3.25 times 25.50. And that is equal to 82.85. So there we go. We just figured out how much it's going to cost to repair this bike. 82.85. Your assignment today, for page 129, choose 7 questions, and let's make it 4 number problems and 3 word problems. Alright, I want you to think through those word problems, see if you can find a strategy that works, see if you can do what we did, pick out the important pieces of information, decide what to do with it, check and make sure you get to your answer in the end, right? This step was finding the answer. Go ahead, good luck.